Hello, and welcome to this special lecture for US 275 Scientific Ethics. In this special lecture, we're going to take a look at geoengineering with the subtitle Manipulating the Atmosphere to Counteract the Effects of Humanity's Manipulation of the Atmosphere. So what is this one about? And so again, I tried to pick timely issues that I thought were interesting, that kind of apply some of the concepts we've applied within, or apply some of the concepts we've learned about within the class. And so this was originally scheduled to occur this year. And so it's an idea of solar geoengineering, this idea kind of led by a group at Harvard that was going to go through and try to kind of counteract the effects of climate change and the warming of the atmosphere. But as we can see in this article from Reuters on March 31st, 2021, Sweden, the country where it was actually going to occur, has rejected the test approval. They rejected or pulled the approval for right now. And it looks like this is going to be on hold now until at least 2022, so probably next year. So what is it? What's going on? Why is it controversial? And what can we learn from this? Okay, so what's the problem? And so if we take a look at this, this is some data that was put together, not the data from him, but Professor Hawkins at University of Reading has put together a website that pulls from a whole variety of different sources, but primarily the Berkeley Earth data sets. And up and through 2019, basically looked at kind of the average temperature in different regions. So on the left-hand side, we've got Pennsylvania since 1895. On the right-hand side, this is how I discovered it. I do some work on an advisory panel for the Ministry of Health in Singapore, so I get a lot of their news. And you can see definitely their pattern is getting hotter. What we've got on this is almost like a little heat map where the blues are going to be kind of cooler temperatures and the reds are going to be higher temperatures. And what they're going to do is they're basically going to say they're going to look at the range of 1971 to 2000 to figure out the average. And so this would be the average in Pennsylvania. This would be determine the average in Singapore. And then they're going to assign the colors based on their relationship to that average. And so the blue colors are going to be associated with standard deviations or kind of a spread of the values kind of below the average. And the reds are going to be a standard deviation or the variation of the temperatures that are above this. And so you can think about this average point as our starting point. And then we're going to use this and say, okay, was the temperature getting warmer or colder in relationship to this? Now, in Pennsylvania, we can see that, if the average is here, we've got some hot years, we've got some cold years, but we've also got some hot years and some cold years kind of prior to that. But you can take a look at it and say, okay, at least it appears as if we're getting deeper reds and more reds in this area, again, indicating that since this period used to average it, the temperatures have been warmer in general than they were, kind of in that previous time. If we take a look at Singapore, and this again emphasizes that the global pattern of climate change isn't uniform. There are going to be areas that are more affected by climate change than others. And so in this case, we've got the average here for Singapore. It's an island nation. Basically what we can see is that pretty consistently, except for maybe one hot year kind of in this region, it was consistently a lot colder prior to this averaging period and definitely consistently a lot hotter in this period of time since that averaging period. And so this is good data that shows that the weather pattern, or at least the climate pattern, is warming across the globe. And so you take a look at this and say, okay, this is something that we should be concerned about. If the temperature is warming, it's going to cause warmer temperatures throughout. It's going to affect the spread of organisms. If you've already seen the mosquito special lecture, you've seen that as the temperature raises, the mosquitoes are able to survive further north than what they would be able to do previously. And if they're spreading to new areas, they have the risk of spreading their diseases in that area as well. There are going to be other organisms that can't survive in those warmer temperatures, and so they will either die off or they have to migrate north to get to cooler temperatures. So this is concerning. But one of the arguments been, yeah, it's warming, but the planet's old. It's been a long period of time, and there's been times in the past it's been hot, and there's been times in the past it's cold. We're just going into a hot phase. And so if we look at this scientifically, what we can take a look at, and this is data pulled from a study that take a look at Arctic ice core samples. They basically go and they find an area of kind of unmanipulated ice that's been there for a number of years, and they take a drill, and it's a hollow drill, and they basically drill down into the ice, and they're able to pull it out, and they study different, almost like layers, different levels within this ice tube that they pull out, and they can get an indication about what was the temperature like at that period of time and the amount of carbon dioxide that was present within the environment. And so if we take a look at this, we see that there's kind of a pattern that's present. So the blue is going to be the levels of carbon dioxide. The red is going to be the temperature that was estimated from these ice core samples. And we can see that basically there have been periods in time where we've had higher temperatures and higher levels of CO2, followed by colder periods of time where we had lower temperatures and lower levels of carbon dioxide. Now, at a global level, this is a cycle that is repeated throughout history of the planet, where we have a cyclic pattern of global cooling, which is generally associated with ice ages, and warmer interglacial periods. And so we're in a warmer interglacial period right now. The question is this interglacial period about to end, or are our activities potentially pushing it off so that this period of warming, this interglacial period, lasts a longer period of time? As I indicated, there are some changes that occur within the tilt of the Earth's axis and the orbit around the sun that affect these cycles as well. And so that was what is occurring previously. More recently, though, it appears as if there is more human intervention in controlling what's going on. Now, these big changes, these global changes in the tilt of the axis and the changes in the orbit around the sun kind of set up the system. But then there are going to be other things that are going to be associated with feedback loops. And so one idea is that when you have more sea ice available, you're going to be reflecting more light. When you have more snow on the surface, you have you have bigger glaciers being present. That would reflect light. And so we see a situation now, here are the, I don't know how to pronounce this, Muir and Riggs glaciers in Alaska. See, 1941 kind of filled in the entire valley, but in 2004, roughly 60 years later, we've got a big lake where we had a glacier previously. This is the Popov Glacier in Russia, and you can see a pattern of glacial retreat, and this is over 1 kilometer long from where it was, 90 years ago. And so this pattern of ice ages and interglacial warming is associated with kind of amplifying, when it's cooling, these glaciers are going to be growing out, which is going to be contributing to more cooling and cooling of the environment, and doing that. As these glaciers are retreating, as the climate is warming, these are going to trigger more warming trends. And there are a lot of things that go into it, but probably the easiest to kind of understand and appreciate is what happens with the ice, what happens with the snow, what happens with the presence of the glaciers. And this is referred to as the albedo effect. Basically, when we're taking a look at sunlight kind of comes in, and when it hits a surface, one of two things can happen. If the sunlight comes in and is absorbed by the surface, that surface then is going to gain energy, and that energy is going to be gained in the form of heat. And so sunlight on a surface is generally going to heat it. But some of the light is going to be reflected. And so the light that is reflected is going to kind of bounce off and go away, but it's not going to be kind of absorbed as heat into the surface that we're working with. And so if you've ever we're gone outside in the summer, and maybe you're barefoot, and you can kind of walk around, but then all of a sudden you stop onto the blacktop, maybe on the driveway, the asphalt that is present there, and that's hot. It's really, really hot because of the heat that has been absorbed, the sunlight that's been absorbed, and that has caused the asphalt in your driveway to get hotter. In contrast, and sometimes it's not easy to tell that, you step onto like a white concrete sidewalk, what you have is more light that's being reflected because the white light is going to be, the white of the concrete is going to be lighter, and so you're going to have more light that is being reflected. And so what we can see is that darker surfaces are going to be associated with more absorption of sunlight, and they're going to be associated with more absorption of heat energy. And so if you've got an area of oceans or forests or even sand, these are going to be relatively dark in appearance, and they are going to be absorbing more heat energy than an area of snow and glaciers and ice up here. And so if we've got an area with lots of, kind of ground cover, we'll talk about, urban islands, cities where we've basically got rid of everything and put asphalt everywhere, it's going to be a great heat sink. It's going to draw in a lot of heat and cause a lot of warming in that area. In contrast, areas that have a lot of snow are going to be reflecting that heat and are going to be associated with a cooler climate potentially. And so what we can see then, if we combine this with that previous slide, taking a look at the glaciers, is that if you have lots of glaciers, it's going to be contributing to a cooling of the environment. If those glaciers are gone now, and you've got water or you've got forests in that area, now all of a sudden we're going to have more heat energy, more light energy being absorbed, more heat energy being absorbed, and that's going to be contributing to additional warming. And so, the changes in the tilt of the Earth and the orbit around the sun kind of get the process started. These other things will have an impact as well. Human activity, though, has been very significant in altering this. And so this is looking at Shenzhen, China, just looking at a period of time from 15 years, from 1999 to 2004. We can see lots of areas just kind of north of Hong Kong over here, or lots of green space. Green space is still better than like urban areas because it's less, green spaces here are less than kind of our urban areas, which would be down here very close to the bottom. And so it's going to be reflecting some of the sunlight here, not heating up as much. But then in 2004, and I can only imagine what it looks like now, 15 years after that, we've got this situation where it's highly urbanized. We've cut it down. We've, cut down the pasture and put up a parking lot. We've got lots of asphalt. This is going to be contributing to urban warming. And so this area has very dramatically changed its local environment because of these changes through human activity, which is contributed to kind of absorption of more heat energy. We can also see this deforestation affecting other things as well. Transpiration is a process where water is basically drawn into the roots of the plants and then evaporates from the leaves. And that's a normal process. That's how the plants are able to draw the water all the way up to the very, kind of tips of the tops of the canopies and all the way out to their leaves. And that's an important process. And it's estimated that the statistics I can find, an acre of corn can transpire about 3,000 to 4,000 gallons of water a day. And so they're going to be taking water from the soil and releasing, 3,000 gallons of water in a day that's going to go into the atmosphere and potentially contribute to rainfall. The water in the atmosphere is going to get up there, and at a certain point it's going to get too heavy. The air is not going to be able to hold it anymore, and that water is going to precipitate and fall down as rain. And so what we can see is that areas like South America, where we're going through and deforesting the Brazilian rainforest to put in plantations, to put in cattle farms, even urban spread, what we're going through is contributing to drought regions. And so we go through, and then all of a sudden we no longer have this pattern of evaporation, this transpiration occurring and rainfall. We're just having minimal amount of water going back into the environment, and then that is contributing to these droughts. Finally, we get to the point of greenhouse gases, the things that everybody's talking about. What is it that they're actually doing? And what we need to recognize is that we have an atmosphere around our planet, which is good. It allows us to have something to breathe, and that, is important. We've got ozone within the atmosphere, and we've got good molecules of ozone in the atmosphere that are going to keep, harmful solar radiation from getting down and, damaging our bodies. Anybody that's been out on a beach in the summer and forgotten to put their sunscreen on knows what solar radiation can do to you. It's painful. You get that nice sunburn, and then you go looking for the solar king to try to take the pain out of it. And so that good ozone, that good atmosphere, is blocking off some of that harmful radiation. So it hits our atmosphere and bounces off. Maybe absorbs some of it so it doesn't all the way down to the surface. But the problem is carbon dioxide builds up in our atmosphere in these lower levels, and that's kind of a bad form of ozone. It's a bad form of materials within our environment because it is basically doing the same thing that the good ozone is doing out here. Sunlight comes in, hits the good ozone, bounces off, and doesn't give you kind of a massive sunburn, as you start to walk outside of your house. But the carbon dioxide in the lower levels of the atmosphere are going to be doing the same thing. Heat is going to be rising up, but it's not able to penetrate through it, and it's going to be bounced back. It's going to be reflected. And so instead of escaping out through the atmosphere and being radiated out into outer space, that heat then is trapped within our atmosphere and is contributing to warming of our climate. And so they describe it as greenhouse gases because it's doing the same basic thing that a greenhouse would be doing over here. Sunlight comes in, it's able to get in, but it's going to keep bouncing around in here. It's not going to be able to escape. And so we've got this kind of heated area, which is really good if you're trying to grow plants in the winter. Not so good if you want to, kind of survive in a warming climate. And so if we talk about this, everyone talks about the weather, everyone talks about the climate, but no one does anything about it. And so, just a quick cartoon to transition to what we're going to be talking about in terms of the science for trying to address climate change. Nikola Tesla was a contemporary of Thomas Edison, and he, had some interesting ideas. One of his ideas was an effort to influence weather by sending electrical discharges into the atmosphere. And this was a slightly different tower than the one he was using to kind of control weather, but it's the same basic idea. They basically kind of shoot electricity up in the air with the idea that it would potentially kind of ionize things. It would change the pattern of wind, maybe change the jet stream pattern, and in doing so, kind of regulate the weather in that area and potentially, regulate the climate potentially as well. And so that's technology that's more science fiction at this point. But there are some technologies that are present that allow us to, control weather at limited levels. One of these examples is cloud seeding. And so the idea of cloud seeding is that you basically shoot silver iodide crystals into the air. These silver iodide crystals are going to be up in the air, and they basically attract water. That water is going to bind to them, and as it binds to them, they're going to start to get larger and heavier. And as those water droplet forms, drops of water in the air aren't going to be able to be suspended in the air. And so individual water molecules floating around are fine, but as they start to become larger and larger and become too heavy, they're then going to drop out of the clouds and they're going to fall as rain. And so what we're seeing on this infographic over here is we got a lot of, maybe, water in the atmosphere up here. Maybe they're bouncing around, forming a few droplets occurring, but we shoot these silver iodide crystals into it, and then all of a sudden we've got large droplets forming relatively quickly, and in doing so, those larger droplets then are going to fall out of the air, fall out of the clouds, and fall down as rain. Now, less science fiction now at this point. This is something that was actually done in China before the 2008 Beijing Olympic opening ceremony. There was clouds that were coming in. They were worried that it was going to rain during the opening ceremony. And so they were basically able to go out, shoot this stuff up into the air, and get it to rain before it got to the site of the opening ceremony. They are now attempting, the Chinese government now is attempting to generate more rainfall in the Tibetan Plateau by going through and consistently cloud seeding. And it's thought that if they can improve the amount of rainfall they're getting in this region, it could be contributing up to 7% of China's water consumption. Again, because it's going to be falling in that area, and it's going to be collected and then used in that region of China. So that's one method that is being used now. There are other ways that we've looked at trying to go through and kind of regulate, things that have happened to the environment. This is an example, and this is an example I discovered last year. This is during the pandemic. We got a inflatable kayak, and this is White Deer Lake up in Pike County, up in the Poconos. We were kayaking on this lake last summer, and I was, like a good scientist, interested in finding out more about the lake and its history. And what I discovered is that this was an area that they did some experiments on limestoning of acidified lakes. And so basically, the acidified lakes are caused by acid rain. So pollutants that are formed by power plants, automobile exhaust, things like that, will get up into the atmosphere, and then it will fall back down as rain, but it's going to be rain that is combined with harmful agents, including acids that will get into these watery environments and often kill native species as well as kill individuals of the species that are surviving. So researchers from Lehigh University a few years back went to this lake and dumped in 100 tons of limestone. They added this lime to the lake and were able to decrease the amount of acidity that was present and show the return of a number of species. It didn't last forever. They had to go through and a few layers later add a little bit more. It's not too expensive, but it is a fairly invasive process to go through and change the chemical composition, in essence, of a natural or somewhat natural lake in the Poconos. And so I just introduced this because I wanted to introduce the idea of kind of regulating things within our environment in different ways. Now, volcanic eruptions have been associated with the release of gases that go into the atmospheres. Some of these gases are good, some of those gases are bad. It's thought that volcanic eruptions in our history have started a pattern of cooling, and then that would trigger some of those other things like the albedo effect, the kind of withdrawal of the glaciers, things like that. And so as we're coming out of the last ice age, a series of volcanic eruptions kind of slowed the warming, and in doing so kind of delayed the warming pattern. We've seen a small example of that in 1991, so roughly 30 years ago, with a volcanic eruption in the Philippines, a fairly large eruption that contributed to an overall global reduction of temperatures of about 0.5 degrees Celsius for a year or two. And so this sets up the idea that potentially we could go through and, kind of manipulate our upper atmosphere, the cloud regions in essence, and maybe slow down this effect of global warming. And so this gives rise to this concept of solar geoengineering. And so these are artificial efforts that are made to try to increase the amount of solar energy that is reflected back into space. Remember that with our atmosphere, sunlight is going to come in and bounce off. But at the present time, a lot of the solar radiation, still a lot of it's bounced off, but a lot of it is getting down and is getting trapped down here. And so we can't do anything about the heat that's down here, and it's bouncing kind of back and forth between the carbon dioxide in the atmosphere and the surface of the Earth. But perhaps what we can do is increase the reflectivity that's present within our atmosphere and decrease the amount of solar energy that is passing through our atmosphere and making it down to the surface of the ground. And so this was decreasing the amount of solar energy that is making it down to the surface by doing something up here within the atmosphere. So the Harvard experiment had a great name associated with it. It's the Stratospheric Controlled Perturbation Experiment, or the SCOPE-X, was put on hold, as we saw earlier last month. But the experiment was basically this idea that they were going to take these basically balloons, hot air balloons. They're going to rise up into the atmosphere, and they're going to have a gondola down here, which was packed with instruments. And those instruments, we're going to measure things like temperature, measure things like the amount of solar energy that's being absorbed by kind of sensors in that region. And then they were going to start to distribute chalk into the atmosphere, just kind of small kind of pieces of fragments of things that would go up and be suspended within the atmosphere. And then the hope was that these chalk particles suspended within the atmosphere would cause greater reflection of the sunlight, and in doing so, minimize the amount of solar energy that is making it down to the surface of the planet. Now, Sweden was concerned about it. The Harvard Advisory Panel basically agreed with them, and they are currently in a pause to build greater public support for this project. But it is an idea that is still out there. It's not been eliminated. It's still thought about as going forward. It's just on hold at this point. So like we've talked about in this course, this now generates some various questions, some ethical dilemmas that we need to think about. Should geoengineering be used to treat the symptoms of climate change, or should we focus on the cause? The process of solar engineering reduces solar energy from reducing and heating the Earth, but it doesn't reduce the accumulation of carbon dioxide in the atmosphere, and it doesn't reverse the effects of ocean acidification. And I didn't introduce that because this was starting to get too long as I put it together. But there are a lot of effects of carbon dioxide in the atmosphere, as well as harmful effects of carbon dioxide in the atmosphere affecting the oceans as well. And so should we be attempting to do this massive strategy of solar geoengineering against climate change, or should more effort be put into reducing carbon concentrations in the atmosphere, reducing emissions, reducing the carbon that's already out there in some way? Limestoning a lake is a local activity. We've seen it, my example here with White Deer Lake up in the Poconos. Sweden has been doing it for a number of years throughout many of their lakes. But if we're doing the solar geoengineering, we're putting stuff up in the atmosphere. It's not just going to stay right above our local area. It's not going to stay above our country. It is going to spread around the world. So who should be involved in making an informed decision about the use of geoengineering? Should the communities involved? But again, it's global, so it's going to affect potentially everybody on the planet. Who should be involved with this decision? Scientists, elected leaders, others? Who should make the final decision about whether or not we're going to manipulate the atmosphere in an effort to offset the human-contributed effects of climate change? What level of acceptance is needed? Is it just a simple majority, supermajority, unanimous? Probably never going to be unanimous, but how do we go about making this? This is a huge decision. We are talking about going through and altering our climate, altering our environment in a way that is pretty significant. It has a great upside. We might be able to, counteract some of the effects of global warming. But is this what we should be doing? Is this the appropriate approach for what we're doing? Should experiments on geoengineering be delayed until we have a better understanding of the processes involved? There's a huge number of interactions associated with the natural warming and cooling patterns. But we've seen that with a large enough stimulus, you can either accelerate or amplify those effects. And so like the retreat of the glaciers is going to be associated with more warming because we've got less snow to reflect the sunlight. If we're going to go through and start to do this, could this trigger something out? Should scientists wait to conduct these experiments until we have a better idea of how to control the effects? How do we turn this off if we get it turned on? Should the implementation of geoengineering be implemented with a safety release, some way in which we can go out there and, capture the stuff that we put out there, or reverse it in some way, or, get it to fall out of the atmosphere so it's no longer out there and having an effect? So again, nothing you have to do with this, but to give you an idea about, some of these dilemmas that scientists are facing in very timely issues. This was an experiment that was scheduled to occur this year. It's now on hold, but it hasn't been canceled. We need to be thinking about this. We need to make some informed decisions. In terms of readings for this, I've got the original article from Singapore that kind of started me along this path. It's nice because it talks about what an urban area can and cannot do in a response to try to maintain its response to extremely, extremely hot weather. I've been there when it's hot. It is very hot and very humid. An Ethics in International Affairs article from 2017, The Need for Governments of Climate and Geoengineering, talking about why is it that we need to come up with a better way of getting approval for these things. And then finally, and this is a good article, not the best source, but a GRIST article, why the experiment dimming the sun got canceled. It goes into some of the concerns that were raised as well. And so, again, we're not doing an essay, we're not doing a discussion on this, but I wanted to give you some greater exposure to some timely scientific ethical dilemmas in science. As always, if you have any questions, please do not hesitate to reach out to me. Thank you, and have a great day.